Okay, so we're starting on page 537, about a third of the way down the page where it says equation conversion. Y'all there? Yesterday we did point conversion from rectangular to polar and polar to rectangular. And we used these sort of, but we had other ways around it because we drew rectangles or triangles. You may still draw triangles, or maybe it's not appropriate, but today we're going to take polar equations and convert them to rectangular, and rectangular equations written in X and Y, I've converted them to polar. If you go to your calculator and hit the mode key, go down there to the fourth line where it says function, par, and the other one is POL and then SEQ. I want you to go to POL, that's polar. Go to polar, and then hit the Y equals key. What do they say now? Yeah, R equals, not Y equals. You know, you gotta, I tried to point this out yesterday, but you gotta kind of get used to this. If you've got a point, start back where we were yesterday. If you have an X, Y, and then you've got, for polar, it's R theta. It told you that you spin the angle first, and then you go out this far on your terminal side, right? So you got to do it backwards. This one you go out right or left. This one you go up or down. You do it in order that you see it. This one's kind of backwards. You spin the angle and then you go out that far when you plot it. It is also true that we have, for equations in rectangular form, typically y equals something with an x in it. Here you will have r, which is sitting in the first position, like x is, but it's not like x. I mean, it's just sitting in the first position. But you will have r as a function of theta. That's the reason why a polar form, it says r equals something. And what follows will have thetas in it. So you gotta get used to that weirdness. We have this, the second one here in terms of the first, and this one is the first one in terms of the second. Just try to acclimate to that a little bit. It's a little bit backwards. Okay, so take a look at the just above example 5. Here's what it says. We can use coordinate conversion equations to convert, that's what I'm talking about right there, coordinate conversion equations, to convert polar form to rectangular form and vice versa. For example, the polar equation, r equals 4 cosine theta. So that's what we're going to do first, even though it's not an example. R equals 4 cosine theta is of this form. It's r equals something with a theta in it. And we wish to write this very same thing in this form, y equals something with an x in it. Or at least an equation that has x's and y's in it. It may not be y equals that. That'll be okay, as long as it's got x's and y's in it opposed to r's and theta. So you look over there at your conversions. Could square both sides. Why would I want to do that?
Then you can make x squared and a y squared. Just kidding, you have a cosine squared theta.
Because now we can replace this with what you just said.
Oh, that's right. Well done. Good job.
X squared
Plus
y squared equals, now maybe I shouldn't have done this. Can you see it more clearly here, what I would write over here?
A little smaller on the first thing.
Oh, now I have to square it. Well, if you're gonna have to square the whole thing anyways, then no, it's
What do you think, Mason?
Am I following this right? I'm not sure where I'm going.
I'm not sure where I'm going.
Oh, yeah.
You put.
Sorry.
Come on, Mason.
I shouldn't have, it shouldn't have been squaring both sides. Although that is an option. You can get an r squared, so you can write an x squared plus y squared. What would have been way better for me, and I think you can see this once I do it, instead of squaring to get an r squared, it might be better if we multiply both sides by r, because that will still give me the r squared on the left, but it'll also give me a an r in here, which is what I need. See that? Sorry, right there.
Yeah.
So if I multiply both sides by r instead, that still gives me the r squared, which I was shooting for, but I squared it. I shouldn't have done that. R squared is going to be equal to 4r cosine theta. That's a little better because it gets me on this side to something that also has a conversion.
Well, that's just straight up X.
Well, it's 4x.
Yeah.
So do you see why I'm still getting my r squared out of it? It was much better to think of multiplying both sides by r rather than just squaring both sides. Because if I square both sides, I don't get an r in there. You following? So that was a poor choice on my part. I wanted this r squared. I was thinking, I don't want them to square both sides. Then I didn't have an r over here, so I had to rethink it. Okay, so now what I have is x squared plus y squared equals 4x. Is that something you recognize?
Heck yeah.
Circle.
Is it a circle? Isn't x squared plus y squared equals 4? Isn't that a circle?
Yeah.
Okay, so we got to do a little bit more work on this to try to figure out what this is. I'll tell you right now, this is a circle. But it's not one centered at the origin. This takes a little more work. We're going to bring this over here. It's going to be x squared minus 4x plus y squared equals 0 for right now. Just for right now. Now we're going to have to do something to this that you haven't done for a long time. So I'm going to remind you how that goes. And I wish I wasn't recording this because then I could use that other board. But I'm going to show you something over here, and I hope you can all see it. Can you still see over this far, this one? I'm going to show you something over here, and then I'm going to erase it. It says only bringing some back a memory. I shouldn't have to leave it up here for you to use as a reference. So leave this alone for just a minute. I'll show you how we're going to work on this after I remind you of something. Do you remember that if I have x squared plus 10x plus 25, that we call this a perfect square trinomial?
Yes.
Do you remember why? How does it factor?
X plus 5, X plus 5.
X plus 5, X plus 5, X plus 5 squared. This is called a perfect square trinomial for exactly the same reason. This is called a perfect square number. It gives exactly the same two factors. Okay? Now, the characteristics of a perfect square trinomial are these. This has to be a 1. Half of this squared has to be this. And it has to be plus that. So, how would you, this is the actual process, what it's called, how would you complete the square on this?
That would be
What?
7 times 7.
You would add, because this always has to be plus, half of that squared. That's a perfect square trinomial now, which factors how?
X squared.
Negative x minus
X
7.
minus 7.
Correct.
Same two factors, right? Okay. How do you complete the square on this one? There's one for you. I'm hearing it.
3/4.
3/4.
Yeah.
What is half of root 3?
Root 3 over 2.
Yeah. What's root 3 over 2 squared?
3/4.
How does it factor? Did you say half of it was that? It's always one of these and half of that when you factor it. Yeah? You okay with this? Okay. This is the idea that we're going to use to fix this up so that we can see and put in standard form this thing right here. And it is a circle, but do you know where its center is? Do you know what its radius is? Well, then it's not a very good circle yet. We have to put it in standard form. Oh, that's another thing. Do you remember the standard form of the equation of a circle that's not centered at the origin? I'm going to put it over here. It doesn't belong with the conversions, but this may be something you want to use today, possibly. It is x minus h squared plus y minus k squared equals r squared, where the center is h and k, and r is the square root of r squared. So if this is minus 4 and this is plus 2, then the center is at positive 4 and negative 2, and the radius is whatever this number is, say 25, square root it. So the radius would be 5, because r square is sitting there. The radius will be the square root of whatever's sitting there. Okay? Yes?
You said h is positive and k is negative?
If you had this, I was trying to get you to imagine it in your head without writing it, but if I had a circle like this as an example, if I had x minus 4 squared plus y plus 2 squared equals 25, then the center would be at the opposites of these. Because this doesn't really stand for negative, it stands for opposite. Okay? And R would be 5. So you would plot that, count out 5, and whip a circle out. You can see a lot more information in standard form. Okay? So that's just to remind you what a circle looks like that's not centered at the origin. So our goal now is to take this thing that we've converted entirely from r's and thetas to x's and y's, and now we got to do some algebra on it and convert it to something that we can read and recognize for transformations. And the way we do that is to complete the square on the x's and the y's if necessary. We only need to complete them on the x's. This is standalone y. There's no other y there. But this one is x squared minus 4x plus what? 4. Thank you. Equals, or no, plus y squared. The reason why I don't need to complete the square on this is because there's no y term. There's nothing to complete it on. Equals 4, because if you arbitrarily add 4 to complete the square here, you got to add it to the other side to keep it balanced. What? So now we have x minus 2 in the factoring plus y squared equals 4. Now we can read it from standard form. Circle centered at what? 2, 0 with a radius of 2. Now, I want you to graph this original thing that didn't have the r's on it. I want you to graph in polar form in your calculator r equals, so you're in the y equals screen, but now it's r equals, and write 4 cosine theta. Make sure you're in radian mode. Now, before you hit graph, don't hit graph yet. If you already have, go back to your y equals screen, or your r equals screen in this case. Are y'all there? Y'all hit the center? And by the way, when you hit your variable key, you'll type a theta in this mode. That's the reason why your variable key has xt theta n. Okay, all right. So you got that typed in there. Now go to the window, because this window is weird too. The window begins with thetas, just like your polar began with t's. Theta, if you want to get the complete go around and collect all the angles possible, what do you suppose the minimum theta ought to be?
2 pi.
0.
0.
What do you suppose the maximum theta ought to be?
2
2
pi.
pi. What do you suppose the theta step should be? Don't think degrees, think radians. So the minimum's going from 0, then it goes from 0 to 6.28 basically. And you want the theta step to be small enough that it doesn't just jerk around. I mean, if you made it 1, it would jerk around like it would look more like a hexagon. Because it would only plot a point every 1 radian and then it would connect them. That's not good. What do you want to let your theta step be?
0.05.
All right, if you want. You could also make it something like pi 30ths. Something really tiny. In terms of pi, you don't have to, but it's kind of nice. Calculator doesn't have to do all the conversions before I can plot a point, but it doesn't matter. It really doesn't matter, as long as it's small. Do you get a circle that appears to be centered at 2, 0 with a radius of 2? Yeah, all right. I got it all done.
It's like, yeah.
You know what else is like really
Oh, mine's
small?
a circle. You guys in radian mode? Yeah, mine's really small.
If yours is football shaped, then go adjust your aspect ratio so that your y's only go from -7 to 7.
Good one.
You need to get that in? Nice.
There we go. That's my circle.
Wait, mine's a quotient, but you said
Is anybody having trouble getting a circle centered at 0, 2? I'm sorry, 2, 0 with a radius of 2. Anybody? Everybody good? So that would be verification that we got it right, because we're able to read this from standard form, and we got just exactly what we expected. How you doing so far? You okay or not? Okay, next one. This next one actually has an example attached to it, so we'll try that one. Please don't look at the solution. See if you can try to start to apply these things a little bit. We have r equals 4 secant theta.
This is seriously.
Okay, listen up. Shh. Shh. I suppose we can start on this one. What would you like to do?
Just throw another R at it.
We should.
We don't have a relationship for R secant.
Four over cosine theta.
You want to change the secant to cosine?
Yeah.
That might be something a little more familiar.
Times both sides by R.
Your instincts tell you to cross multiply, don't they?
Times by cosine.
Yeah, times both sides by cosine. In other words, cross multiply. Doesn't that feel instinctive by now?
Yes.
I have R cosine theta equals 4. Oh, hey, there's a happy thing. What is it?
X equals 4.
Yeah.
That makes more sense.
What is that thingy? Do you know what that is?
Just a straight. It just.
I love it when people say it's a straight line. All lines are straight. Describe it better. A what? Vertical line
That goes through 4.
at x equals 4. So if we were going to graph it, it would be like this. Seems awfully strange. It seems like when you have r's and thetas, things ought to turn out curvy some way or another. Graph this. Type r equals 4 over cosine theta. Type it in that way and see what you get. They're all straight.
Shit, how did you get the bottom so straight on that? It is like perfect right there.
Oh,
Nice.
nice little circle.
She just.
I'm almost there. I'm
Good.
also almost there.
Wow.
That's impressive.
Wait, how do you?
Vertical line of 4, right? Okay, that's what we expected. Well, maybe you didn't expect that, but that's what we got. That was right. Turn the page. This is going to get even more exciting. Now we're going to go rectangular to polar.
Yay.
Yay!
Wait, what are we doing?
Please don't look at the solution to this one either. Let's see if we can think the other direction now and try to get. We got rectangular, and the rectangular is x minus 3 squared plus y minus 2 squared. Does it say 13?
Wait,
I have a question.
Yeah.
When it gives us the 13, is it in its reduced form or the squared form?
Well, if you want to know what the radius is, you'd have to square root 13. That is r squared. So this is, so we all right, do you recognize this as a circle? Centered at what?
3.
3, 2, and the radius is about what? 3 point something. 3 point something, because 13 is between 9 and 16. Slightly, ever so slightly closer to the 16, so it'll be 3.5 something. Okay, all right. So, we know what this thing looks like. That's not the goal. The goal is to convert this to something that will graph exactly that circle centered at 3, 2 with a radius of about 3.6. But we want to write it in polar form. Do your instincts tell you anything?
All those things apart. You could square them. Foil those things.
You want to square them? You want to FOIL them out?
Yeah.
What does this one give you?
X squared.
Minus what?
6x.
Plus 9.
Y squared.
Minus
4x.
Plus 4.
Okay.
It'll be 4y.
Oh, yeah. Yeah, thank you. Thank you for that. Yep.
Now.
That's nice. Now what?
Combine like terms.
I like terms.
Yeah, we're like the 9 and
Never
4.
heard of it, man. Combine it out.
Yes.
Thanks, Cash. Whoa, yeah, you're right.
He's also
X squared minus 6x plus 13.
How about this?
Oh, minus 6x minus 4y equals 0.
Oh, yeah.
So look at that.
Hold up.
Yeah, makes sense.
4 add up to 13.
Then, remember what we're doing. We're trying to convert it to something with r equals something with a theta in it.
R squared
equals
minus
6x plus, wait, you just leave that there?
Minus
What?
6 cosine theta.
Why did you just throw that out there? Did you actually have reason for that?
No, because if we're getting it in the polar form.
Oh, yeah.
R cosine theta.
The cosine theta. Yeah, it's
Kyle.
four hours, 6:15.
Wait, can you explain that stuff?
Oh,
over.
It's right there. It says equals to R
No,
cosine
I want
theta.
her to
You heard
Oh.
articles.
So we got R squared.
Yeah.
Getting that.
Y'all see what happened?
Oh my gosh.
X became R cosine theta, Y became R sine theta, and X squared plus Y squared became R squared. Because we're converting. So any place there's an X, we put in R cosine theta. Any place there's a Y, we put in R sine theta. And wherever there's an X squared plus Y squared, we put an R squared.
Let's factor in an R.
Oh, well, let's make sure everyone wants to hear first. Are we okay or not? Yeah, Kyle keeps getting thumped, so you were justified there. Is there anyone who doesn't understand how we got from here, well, from all of these steps? Anybody stuck anywhere along the way? Okay, so you wanted to do what?
Factor out an R.
Okay, if we take out an R, what will you get?
R minus 6 cosine theta minus 4 sine theta equals 0.
Okay. So, we've been in this situation before where we've got two things multiplied that give you 0. If this is the one that's 0, then R is 0, right? And think about what R equals 0 is.
That's nothing.
It is a point at the origin. It's called a degenerate form. It's degenerate.
You're in degenerate.
So, since R equals 0 is an option, but R equals 0 is just a point, we're going to not consider it. We're going to consider this one being 0, in which case R equals 6 cosine theta minus 4 plus 4 sine theta. Done. R equals something with a theta in it. This is it. Furthermore, this particular circle actually goes through the point that this would have given us at the origin. So it's contained in here, so this can be ignored even further. Okay? Graph this in polar mode.
She left the article below, so positive and moved everything over.
I was letting that be 0 and I kicked the negatives over. So that I had R. Because that's what we do in polar mode. Okay, so graph that and see if you got the circle you expected. Does it look like the center's at 3, 2?
Yeah, it does.
Does it look like it has a radius of about 3.6?
Yeah, that's actually
Oh, excuse me.
Then if you grab that,
Everybody okay? Or did you get that graphed and are convinced we're right? All right. One more example. Finding distance using polar coordinates. This is not hard. Here's the situation. We're in a control tower where they're controlling the landing of airplanes at an airport. And we got a couple of airplanes out there at the same altitude. So we're not considering a difference in altitude. They're on a single plane, a plane of flight. They are up above the same one so that we can put them on a two-dimensional grid. Okay, you with me there? So they're at the same altitude. And this is what with the information that we know. It says radar detects two airplanes at the same altitude. The polar coordinates are 8, 110. Ooh, now we're getting some degrees. One of them is at 8 miles, 110 degrees.
Oh.
And the other one is where?
5 miles, 15.
5 and what?
15.
Okay, so what we're doing is it's kind of a bird's eye view. We got these two airplanes. We're looking down on them here. We're putting a grid right here where the airport is, where we are at the control tower. And from there, we can look out along the grid and see these two airplanes at the same altitude. One of them is located out here at 8, I'll say, is right there. And okay. If I spin that 110 is a little past 90, right? 20 degrees past 90. If I make that one 8 long, we'll say that I'm not going to put that on there. We'll just call it 8. The other one is at 5:15, so it's going to be a little shorter and pretty shallow. This right here is, we'll say, I'll just remind us that this is 20 and this is 15 right here. But this is really 110. Okay? What we want to find out is, what's the distance from this airplane to this one? That's what we want to know. Yes, we can. Law of cosines.
I like the one.
Law of cosines would be great. In
Yeah.
order to use the law of cosines, though, we need the angle that's in between the two sides. What is this angle right here? 95. It is. It's 95. It's 110 minus that 15. So we can find that distance using the law of cosines this way. Question mark, which I'm going to D for distance. D squared, that's the side opposite the angle I know, is going to be equal to, using law of cosines, 64 plus 25 minus 2 times 8 times 5 cosine of 95. What's the first thing you better do? What's the first thing you better do before you start calculating? Get back to degrees. Your mode is critical.
You got us there.
Nine point eight
9.8 what?
miles.
Yep. Is that what the book says? Awesome. Not very hard.
I got 9.0.
Hey, that's what I got.
Not very hard at all. When they give you practical applications, especially with polar points in degrees, chances are you're going to be drawing some sort of triangle. Put it together and remember what you know. Okay, you all right with this, you think? Okay, good luck. The assignment is given and it is 14 questions. Shouldn't be too bad.
All of it.
There you go. See ya.
Change.